We're doing Unit 2, Lesson 5, so we're solving quadratic equations using factoring. So what we're doing now is essentially, like I told you in the very beginning, is that we use factor to help us find roots, zeros, and x-intercepts. Well, we're kind of making that connection with factoring today. And then when we get to Unit 3, we pull it all together in terms of different ways that we're going to solve using factoring and other ways that when things aren't factorable. Okay, but anyways, so what we're going to talk about first, okay, is complete the following. So statement x minus 3 equals 0 is true if x is what? So essentially, if you solve for x, you would just do what? Add the 3, right? So it would just be x equals 3. Okay? So if x minus 3 equals 0, then your 0 is 3. Okay? So there's just opposites the way I kind of see it. You see x plus 1, what makes it 0? Negative 1. So then if we had the factors of x minus 3 and x plus 1, your zeros are 3 and negative 1. Now this is why. If I put a 3 in here, we know 3 minus 3 is what? 0. What's 0 times anything? So it's irrelevant if the second one's not 0. Okay? So when you're doing factoring, the zeros come from either factor. Okay? And so that's what we're going to work on today. So 3 and negative 1. And then so how about this one? X times x plus 1. What are the zeros? I'll give you a hint. How many x's you see is typically how many zeros you have. So how many x's do you see? 2. So what are your zeros? What are the zeros from that picture right there? Negative 1 is one of them, yep. And what about that guy? 0, okay? Nothing, there's no plus or minus with it, so if this guy is 0, everything's 0. So that one's just the 0. Okay? So how this works, just think about it. If I put negative 1 in, negative 1 plus 1 is 0. 0 times anything is 0. If I put 0 in, 0 times 0 plus 1, well, 0 plus 1 is 1, but timesing by 0 still makes it 0. So those two are the zeros, or solutions, for those factors. And that is the zero product law. And that's what we're working on, like I said, that's what we're working on today. So if you're not quite there yet, just stay with me. We're going to do tons of examples, and hopefully it'll stick. Okay? If there's questions, just feel free. Okay? All right, so the zero product law itself says the last two statements in the investigation above are example of what's called the zero product law, which states the following. If the product of multiple factors is equal to 0, then at least one of the factors must be equal to 0. So that's what I just said. If you know that it equals 0, then one of the factors has to be 0. Say if a times b equals 0, then a is 0, or b is 0 as solutions, just in terms of definition. Okay, so let's complete the following by solving for x in each equation. So we solve for x here. X is 0. So this one, you could divide the 8 if you want, but you can see it's really not relevant, right? Because x plus 2, what makes an x plus 2 0? Negative 2. What makes an x minus 7? Plus 7. So what they're showing you here is this 8 doesn't change your zeros at all. Okay? Yeah. Like this? Yeah, you just have to write it twice. Yeah, you have to write it as 2. You can write, I mean, if I guess what you're saying, you could write like this. That's fine too, if you want it. Is that what you mean? Okay. Okay, we'll keep looking at some more. So this one, how many x's do we have see for C? So that means this is actually this is a cubic, so it actually has 3 zeros. Okay, so it crosses 3 times to the x-intercept. So it crosses, we know that's the easy one now. That's 0. Okay, negative 2, and 7. You'll get good at these ones. They'll be very quick for you. I'm going to do it the long way for these couple, but you'll just see that you're always going to do the opposite of this and divide by this to get the answer. So I know right off the bat that this one's negative 1/2. If you don't see that, that's okay. I'm going to show you right now. We know that inside that bracket we want to be 0. So see, you minus the 1, you divide the 2. And so that's what you can do to find that answer every time. So like here, add the 2, divide the 3. So 2/3, okay, for the second one. Okay, I'll do that one as well, just so you can see the actual algebra. Add the 2, divide the 3. And so there's your 2/3, okay? So that's what happens when you have a coefficient that's not 1. Okay, you're going to have to divide that coefficient Okay, a lot of people, when they first start, they say, oh, it's -1 and +2. Yeah, but you have to divide by the coefficient. Okay, all right. Why is it acceptable to divide by 8 in the first? Is acceptable to divide by 8 in the first A and B? Well, it's acceptable because you're doing it to both sides. Even though it's to 0, nothing happens, but you're doing it to both sides. It says, why is it not acceptable to divide the first by x? You can't divide by something you don't know. Because what's that mean? We don't know what that value is. Okay, so you can't divide by something you don't know. We know what 0 divided by 8 is. It's 0. Okay, so that's what you could write here. So because 0 divided by 8 is a value, and then here, why is it not acceptable to divide by x? We don't know what x is. Okay. All right. Okay, so let's get some examples now. Okay, so all the above equations are polynomial equations in which one side of the polynomial equals 0. Okay, the solution to a polynomial equation is given by stating the values of the variable which makes the left side equal to the right side. We know that, and we can use zero product law to help us with that. Okay, so we're going to consider the equation x squared minus 2x minus 3 equals 0, factoring the left side equals to x minus 3x plus 1. This is true if x is 3 and x is -1 for your solution. So remember, x minus 3, so it needs a +3. X plus 1, we need a -1. The solution to that equation is 3 and -1. Okay, so here's kind of, I don't know if this answers all justice, but this is how you can write it here, or like I said, with a comma. You can write it either way in terms of your solutions. Now, second one, what are factors of 20 add up to -9? Yeah, 5 and 4, 4 and 9. Okay, so x minus 4, x minus 5. So that means my solutions come from solving these little equations, which we'd add the 4, add the 5. So the answer is a +4 and a +5. Again, these solutions represent where these are parabolas. This is where the parabola crosses the x-axis. So if I just drew you a quick sketch of what this could look like, that means it's doing something like this. I missed the 4, but going through 4 and 5 there. That's what's happening. Okay. All right. Solve the equation of the zero product law. So now this is what I'm talking about. We're going to combine what we knew from the first 4 lessons, and we're going to factor and state the zeros. So x squared minus 81 should stand out as a difference of squares for you. So x plus 9, x minus 9. So your answers is 9 and -9. That's your solutions. Okay. All of these look like there's all these look like there's some sort of difference of squares. So let's look here. 4x squared minus 9, well, except for c. 4x squared minus 9, so that's to be 2x plus 3, 2x minus 3. So we have factored. So then I said minus the 3, because that's a positive, divide the 2, add the 3, divide the 2. So your solutions are -3/2 and 3/2. Okay? Yeah, that's fine. If you want to write as a mixed number, that's fine. Okay, C. So like I said, we can GCF here. They both have a 10 and they both have an x. So it's actually going to be this. It's going to be 10x times x minus 9. So that's factored, right? I can't factor x minus 9. It's not different squares because the x isn't squared. So there's your two solutions. What are they? X is 0 and 9. Good, you guys said it together there. So the 10x, the x has to be a 0 because 10 times 0 is 0. And the x minus 9 is a -9, so we want a +9. Okay, anything else? All right, and the second one there is very similar, but you can see the 9 doesn't have an x. So this time we pull the 10 out, we will have a difference of squares. We'll have x squared minus 9 because we didn't take an x out. Okay, and this will be 10 times x plus 3, x minus 3. So then my question is, does the 10 affect your zeros? No. Good. And that's going to come into play in Math 30, okay? This is called a vertical stretch. It doesn't affect anything laterally, like your x values. So your answers are -3 and +3. Okay, let's go and see if you guys can put together here. So why don't you guys try A, and then I'll do B with you. But try A with decomposition there. Okay, for this one here. All right, I'll just kind of go through it as you're finishing up here. Some people are done, it looks like. So this is decomp. I can't take anything out of this one to start. I can in B. We'll do that in a second. And then B is also a problem because it's not equal to 0. We'll fix that. But for A, though, 3 times -10 is -30. Factors in -30, it's -13. That'd be a -15 and a 2. So we go 3x squared minus 15x plus 2x minus 10. GAC that up there. 3x out of the first one gives me x minus 5. 2 out of the second one gives me x minus 5. So 3x plus 2x minus 5 equals 0. So my solutions are minus the 2, divide the 3, so -2/3, and 5. Okay. So again, so it says solve the equation. When it comes to quadratics or it comes to solving by factoring, we want one side to be 0. So with B, we want to add the 25 over really quick because we want this side to be 0. So we go 5x squared plus 30x plus 25 equals 0. And now we're ready to use our methods. Okay, so first thing I'm going to do is take a 5 out. They all have 5 in common. That means I can use inspection, which is also easier than decomp. So we're here. Factors of 5 that add up to 6, a nice easy one. Factors of 5 is only one option, 5 and 1, and that happens to be 6. Over here. And your answers are -5, -1. That's it. Okay, any questions before we get to the application ones? A little more wordy problems. Okay. Like I said, the hard part, or the new part today, is just knowing that you're essentially trying to find out how to make these binomials equal to 0. That's what you're doing today. Okay, everything else you knew how to do from factoring. All right, the application pieces. So here's the steps to using them. Pretty good steps. Just introducing a variable to represent unknown values, form a quadratic equation for the given information, solve the quadratic equation using the method we just showed you, and then state the solutions. So biggest thing is identifying a variable. Okay, that's where people get stuck on these. You feel like you don't have enough information, which you're right, but you're solving for that information. So let me show you what I mean here. Area of a rectangular sheet of paper is 300 square centimeters. The length is 5 more than the width. Form a polynomial equation and solve to determine the perimeter of the rectangular sheet. So we're going to solve for the perimeter by knowing the area. So we know the area is 300. Okay, what's the unknown value here? The width, very good. The width's unknown. We know the length in terms of width, right? So what we do is we call our width, I'll call this W, we'll call this, sorry, that's the width, we'll call it X. Just use it a variable, right? And the length is 5 more. So then the other side is X plus 5. You've identified your variables now. Any questions there? That's the hardest part right there, the comprehension. Okay? So they kind of don't tell you anything about the width, but they tell you the length's 5 more than that. So here's the width. That's just our unknown. The length is 5 more than the unknown. So we know area is x times x plus 5 equals 300. So that we'll just distribute, and we're going to move the 300 over so that it's equal to 0. And we're going to factor that. Okay. Factors of 300 that are 5 apart. Anybody get that quick, or what do you think? $20 and $15, good. So 20 and 15 means x plus 20. X minus 15 are the two numbers I want. Okay, and just FYI, when you're doing stuff like this, it actually is telling the two sides because this is a length, right? We're solving for a length. So see how my answer is -20, and then my answer is 15? Which one is not possible? We can't have a -20 length, right? I can never be -20 for a length. That's not possible, okay? 15 is my length. Now, it's not a coincidence. This is why. Because that 20 represents the length. Okay, our width is 15. That's what x is. The other side is 20. It's 5 more. Okay, so that negative 20, I mean, it's misleading in the sense it's not the width, but it does give you the idea what the length is going to be. Okay, the question does say to find the perimeter, though. If you didn't see that, we are not quite done yet. We just know we have to add up all the sides now. So the perimeter, 15 plus 15 is 30. The perimeter is 70 centimeters. Okay, any questions at all? It's a good applied question there. Good? All right, last question here. Yeah, this is the last one. Goes a little bit to the next page, but this is the last one. Okay, so the diagram shows a cross-section of a water trough whose sloped sides AD and BC make an angle of 45 with the horizontal, the length DC of 36. Okay? Show that the area of the cross-section is x times 36 minus x. So they're talking about the cross-section. I think they're talking about this section here. Okay. So you kind of think about it as 3 areas. So we have a triangle, we have the cross-section, and then this here. Actually, let's name the cross-section A3. Since these are related, this is the one we want. Okay. Okay, so what we're going to do first is we're just going to write each in terms of area. So what is A1, what is A2, and what is A3? How can we write them? Right, base times height divided by 2. And then kind of the thing that they don't really tell you here, it's kind of tricky, is that if this is x, it's a 45-degree triangle, what is this? X, right? Because these are isosceles. That's the thing they don't really tell you. That has to be 45 too, right? So if 45 degrees makes x in a triangle, then this 45 degrees also makes an x. So these are both x. And so then like Nick said, it's going to be x times x divided by 2 for the area. So 1/2 x times x, which will simplify to 1/2 x squared. And that's the same thing for A3. Okay. Or A2, excuse me. The other triangle. I wrote it in A3 though. Oh, son of a. All right. 1/2 x times x, 1/2 x squared. A2 is also 1/2 x squared. All right, now, so A3, how can we represent A3 then? Because remember, we're just doing the rectangle here. So it's x times, what's this length? 36 minus 2x, because it's the whole thing minus those x off, right? Good. So it's going to be x times 36 minus 2x is A3. Okay, which we can write as 36x minus 2x squared. Okay. So either of these ways is how you could write A3. So we just already did this. Sorry, 36. Okay. 36, yes, okay. Oh, total area of the cross-section. Sorry, the total area means they want the whole thing, not just the middle, excuse me. Okay, they want the whole trough. Okay, so what we're going to do is we're going to add all these, okay, and see what's A1 plus A2. 1/2 x squared plus 1/2 x squared is what? It's just 1x squared. So we're going to add an x squared, and then you can see the like terms here. Negative 2x squared plus x squared makes it 36x minus x squared. And then we can pull the x out, and then you can see we get what they told us we would get. Okay, so that's the representative area of the whole trough, is 36 minus x times x. Okay. In part B, we're just going to, on the next page, tells us what the area is, and we're going to solve for x. So that part for this lesson. So it tells us that the area is 260. Okay, so we're going to go ahead and change that back to a 36x minus x squared equals 260. Okay, now what I'm going to do here is I'm not going to move the 260. I'm going to move my variables to the right. Does anybody want to guess why? Why am I going to move these over? So my x squared's positive, okay? It's a little bit easier when your x squared's positive because you don't have to worry about flipping anything. So I'm going to go minus 36x, and I'm going to add x squared over, okay? So that gives me 0 equals x squared minus 36x plus 260. You can kind of see that one, can't you? It's 260 times, 26 times 10. Okay. So that means my answers are 26 and 10, but we need to check them. Okay, so if we check them, that means that all of our stuff has to make sense. What I mean by that is if you go through and plug your values. So if we look at the rectangular section, remember the rectangular section was 36 minus 2x, right? If I plug 10 in there, what's 36 minus 20? 16. Seems reasonable. But if I put 26 in there, you can kind of see what the problem's going to be. You're going to get minus 52. You're going to get negative 16. This one is not good. That's going to cause one of your sides to be negative, which is impossible. Okay? So x can't be 26 when you check your sides. Okay? And that's it.